obvious now. Intro.
So hello my dear students, welcome to IMS GATE Academy. Hi, I am Vipin Mishra and you are watching most expected concept series of IMS GATE Academy. And in this series, I am taking a very important subjects for all EC aspirants, and that is none other than but electromagnetic field theory, EMFT. So this is going to be the fourth lecture. We have already taken 3 lectures, okay, and in those 3 lectures, the first 2 were dedicated to transmission line and third lecture was dedicated to waveguide. This fourth lecture will be on electromagnetic wave propagation, another very important topic, okay. So after this lecture, we will be in the stage where we have completed all 3 important chapters of EMFT for all as far as the GATE exam is concerned, okay. So let's get started with electromagnetic wave propagation. Now what we used to do, in the last session what we used to do, generally first of all I discuss with you all the important points and questions, but in this chapter there are a lot of important points and formulas. So I am not going to discuss all those formulas, but I will be discussing whatever formulas and important points needed to solve any GATE questions. Okay, so let's get started with the questions directly. So let me take you to the first question. So this is the first question that I have in EM wave propagation. So what it says, just read with me. Question number first is the electric field in an electromagnetic wave in vacuum is described by this equation. E is equals to E max sine kx minus omega t. Hello Vijay Agarwal, nice to see you here. Welcome to IMS GATE Academy. I hope you are doing very well. Where E max is given 100 Newton per coulomb and K is given 1 into 10 to the power 7 per meter. The speed of light is 3 into 10 to the power 8 meter per second. What is the amplitude of corresponding magnetic wave is what we have to determine. So E is given to us, we have to find the magnetic wave, means we have to find H. But can you see the options that we have, the options are given in Tesla. So we don't have to find B, in fact we have to find B. In order to find B, first of all you have to find H. Okay, B is equals to mu H is what you need to do then. Okay, so I am giving you 1 minute of time for this question. I think 1 minute will be sufficient. And let me see whether you can solve this question or not. E is given, E max is given, and the wave is traveling in free space, isn't it? In vacuum, okay? So we have to find first of all H, and then we have to determine what will be the value of B. Last 10 seconds. Okay, so just see, we have been given with the value of E max, isn't it? And the wave is traveling in vacuum. So vacuum or free space, in vacuum or free space, what is the impedance? So intrinsic impedance that we will be having will be 120 pi, isn't it? Now, as V by I is R, isn't it? Similarly, E by H is equals to neta. We all know about that. So, we have a relation that E upon H, that will be equals to neta. Now, what will be H here? So, H will be E over neta. What is E? E is given 100. Okay, the maximum value of E is given 100. Divided by neta will be 120 pi. So, how much we are going to get here? So, from here we are going to get 5 by 6 pi. So that will be the value of H, isn't it? but the answer that we have to give for magnetic wave is in Tesla. So that means that we have to find B. So what is B? B is basically equals to mu into H. We are talking about free space, so mu will be 4 pi into 10 to the power minus 7. And what is H? H is given 5 by 6 pi. So how much will be the answer? So if pi and pi get cancelled, okay, we will get 2 by 3 here, or ultimately we will get 10 by 3. 10 by 3 means 3.33 into 10 to the power minus 7 Tesla, and that will be the answer. So the correct answer will be option number C. The correct answer will be option number C. So that's how we can solve this question very easily. Okay. So this was very easy. Now as we will move further in this lecture, the level of question is going to increase. So let me take you to the next question. So the next question that we have is this. And what has been said in this question is, an electromagnetic wave is traveling from air to medium. Okay. From air to a medium. So air to medium we are traveling. Okay, so wave is getting into from air to medium with mu r equals to 1 and epsilon greater than epsilon naught. Okay, so here we have mu r which is equals to 1, and here the epsilon 2 that we will be having is greater than epsilon 1. Okay, where epsilon 1 is the permittivity of this medium, and this medium has a permittivity of mu naught. Okay, epsilon naught. Similarly here mu will be mu naught only. Okay, so epsilon 2 is given greater than epsilon 1. Neta 1 and 2 are the intrinsic impedance. So we have intrinsic impedance here neta 1 and intrinsic impedance here is neta 2. So this is air or free space. So you know here the intrinsic impedance will be equals to 120 pi of medium 1 and 2 respectively if percentage of power transmitted is 75% of the incident power. Percentage of the power transmitted. So what has been given to us? Power transmitted with respect to the incident power. Okay, that is given 75%. Okay, then percentage change, we have to find what will be the value of neta 1 minus neta 2 divided by neta 1 into 100. So what will be the value of this factor? This is what we have to determine. This is what we have to determine. So this particular data is given to us. Now we have to determine what could be this particular ratio. Okay, what could be this particular ratio? So again I am giving you 2 minutes for this question. So all the data given we have written. Now I think that you can solve this question very easily. So last 10 seconds. Okay, see how we can solve this question. So this much data is given to us. Okay, we know the value of intrinsic impedance neta 1 and neta 2 is the intrinsic impedance of second medium, and this is what we have to calculate. So first of all we have to find what will be neta. So from the given data, so given data is that PT over P incident. Okay, we know that this is equals to 1 minus gamma L square. Okay, and that has been given to us 0.75, or what we can say 3/4. So from here what will be the value of gamma L? Just calculate the value of gamma L. This will be 1 minus 3/4 or 1/4. So what will be the value of gamma L? That will be plus minus plus by 2. Now whether positive value or the negative value, which value we have to take, this is what we have to decide. Okay, so how we will be deciding this? Gamma is either plus 1/2 or minus 1/2, the reflection coefficient. So from the given data, the ratio of power, we can find the reflection coefficient. Okay, now after that, you know that gamma L is equals to neta 2 minus neta 1 divided by neta 2 plus neta 1, isn't it? And what we can write for it? We can write it 120 pi divided by mu r over epsilon r, isn't it? Mu r upon epsilon r. Or let me not write here, let me tell you separately. You know that the neta value is basically equals to mu upon epsilon, or what we can write it 120 pi upon mu r upon epsilon r, isn't it? This is how we can write it. Okay, this is how we can write it. Now mu r is given to us. Mu r is basically equals to 1. Okay, so if we replace this formula here, what we are going to get? We are going to get mu r2 divided by epsilon r2. Okay, and here we will be getting mu r1 divided by epsilon r1. Similarly, we can write in the new denominator as well, mu r2 divided by epsilon r2 minus mu r1 divided by epsilon r1. Okay, or since epsilon mu r is given 1, okay, so what we can write this equation to be 1 upon under root of epsilon 2 is the relative permittivity of the second medium divided by epsilon 1. Okay, like that we can write it. Like that we can write this equation. Okay, so this is what we have in place of gamma L. Now as Rakesh Balchand, love the way you run over each topic, sir. Thank you so much. So reflection coefficient is given to us. Okay, now what has been given to us is that gamma epsilon 2 is greater than epsilon 1. So if epsilon 2 is greater than epsilon 1, this ratio will be less and this ratio will be more, isn't it? Best solution guider, thank you. So this ratio will be less and this ratio will be more. So guys, ultimately the gamma value will be negative, isn't it? So from here we got a solution. If epsilon 2 is greater than epsilon 1, which is given as that epsilon is greater than epsilon naught. Epsilon naught is the permittivity of the medium 1 and epsilon is the permittivity of the medium 2. So from this data what we can refer is that gamma L will be negative, and if gamma L is negative, so we are in a quest to choose either positive or negative value. So that has guaranteed that gamma value will be minus of 1/2. So from here we got a solution. Okay, from here we got a solution, and what solution we have obtained is that gamma L will be having a value of minus 1/2. Okay, so gamma L will be having a value of minus of 1/2. So that's what we have obtained here. Gamma L will be having a value of minus 1/2. Okay, so we have got the value of gamma, which is minus 1/2. Again apply the formula. What is gamma L? Gamma L is basically neta 2 minus neta 1 divided by neta 2 plus neta 1, isn't it? Now gamma L value that we have is 1/2. Neta 2 is the impedance of the second medium, and that we don't know. What is neta 1 is the intrinsic impedance of the first medium, and first medium is basically air. So for air it will be 120 pi divided by neta 2 plus 120 pi. Now we have to solve this equation, and if we are going to solve this equation, what we are going to get? Okay, so this will be 2 times minus neta 2 plus 120 pi. So just solve this equation and see what we are going to have. Twice of neta 2 plus neta 2, that will be equals to minus of 120 pi, and that will go that side, so it will become 240 pi. So what we are going to get, this will be thrice of neta 2, this will be equals to 120 pi, or neta 2 that we will be having is 40 pi. Okay, so this is how we have found out the solution. What do we have right now? So just see, what do we have right now is, we are having the value of neta 1 with us. Neta 1 is 120 pi, and we are having value of neta 2 right now, which is 40 pi that we have calculated. What we have to calculate here is the ratio of neta 1 minus neta 2 upon neta 1. So neta 1 minus neta 2 divided by neta 1 into 100 will be how much? So put the values here. 120 pi minus 40 pi divided by 120 pi into 100. How much we are going to get? This will be 80 pi over 120 pi into 100. Okay. So how much it will be? How much it will be? 8 by 12. Or we will be getting 2 by 3. 2 by 3 is 60.6. So ultimately we will be getting 66.67%. So that is going to be the answer. So this is how we can solve this question very easily. Okay, have a look again. So guys, from the given data we can determine the gamma L, and gamma L will be positive and negative both sign it will be having. So which value we are going to choose here? That we have determined based upon the given condition and with the help of gamma L, the formula of reflection coefficient, isn't it? And after that, again by using the same formula, since we have right now the value of gamma L, so we can find out what will be the intrinsic impedance of the next medium, second medium. If we know neta 1 and neta 2, we can easily find out this particular ratio, this particular quantity given to us. So this is how we can solve this question very easily. Okay, so let me move to the next question. So this is going to be the third question, and read this question with me. What has been given here is, an electromagnetic wave has an electric field EZT. Okay, so the wave is traveling in Z direction, equals to 5 e to the power minus alpha z e to the power j 10 to the power 8t minus beta z. In a homogeneous medium with sigma conductivity is given, mu r and epsilon r both are equals to 1, the attenuation constant alpha and skin depth delta will be what? This is what we have to determine. So what we have to find? We have to find what will be the value of alpha. We have to find what will be the value of delta. So alpha and delta is what we have to calculate here, and your time starts now. Okay, your time starts now, and I think 1 minute will be sufficient for this question. Same kind of question you can expect to be in the upcoming GATE exam as well. So see how we are going to solve this question. Okay, so we have been given the value of E. What is the value of E? E has been given to us. E we will write in this format: EM e to the power minus alpha z e to the power j omega t minus beta z. Okay, this is how we are going to write this expression of E. Now as you can see here, the value of omega, what will be the value of omega? So if we compare both the equation, the value of omega will be 10 to the power 8 radian per meter. Okay, and we 10 to the power 5 Siemens per meter, and mu r and epsilon r, they are equals to 1. Okay, So first of all, we have to find the ratio. Whenever you are in this situation, the medium is given, it is homogeneous medium, but whether it is perfect, whether it is good dielectric, or whether it is partially, okay, that we don't know. So we have to determine that. So for that we need to calculate the ratio of sigma upon omega epsilon. Okay, sigma upon omega epsilon. How much is sigma? Sigma is 10 to the power 5 divided by omega. Omega is 10 to the power 8. And what is the value of epsilon? Epsilon will be epsilon naught, epsilon r. So epsilon naught and epsilon r is given to us. Epsilon r is 1. Okay. So if epsilon r is 1, epsilon naught we can put 10 to the power minus 6. We can write it 10 to the power minus 9 divided by 36 pi. Okay, so how much it will become? This will become 36 pi. Okay, this will become 36 pi into how much it will be? 36 pi. Above we have 10 to the power 5 and below we have 10 to the power 8 into 10 to the power minus 9. So we will be having 10 to the power minus 1. That will go up and it will give us 10 to the power 6. Okay. So what we can see here is sigma upon omega epsilon is greater than 1. So that means it is good dielectric. Okay. It is good dielectric. So in case of a good dielectric, what is the value of alpha? In case of a good dielectric, sorry, it is a good conductor, not a good dielectric. It is a good conductor. Okay, so in case of good conductor, we have to find this ratio first of all. If this ratio is greater than 1, it will be good conductor, otherwise it will be a good dielectric. So both are having different formulas for alpha. So first of all, we have to determine this ratio. Okay. So this is good conductor. So for a good conductor, what is the attenuation constant? Attenuation constant is under root of omega mu epsilon divided by 2, isn't it? This is the formula. Under root of omega mu and sigma is there, not epsilon. We will be having sigma here. Okay. So we will be having sigma here. Now just put the values here. So what values we are having? Omega is 10 to the power 8. Okay, omega is 10 to the power 8. Mu will be mu naught into mu r. Mu r is given 1 and mu naught will be 4 pi into 10 to the power minus 7. So 4 pi into 10 to the power minus 7. And what is the value of sigma? It is 10 to the power 5 divided by 2. So what you need to do is to solve this equation. So after solving this equation, how much we are going to get? 10 to the power 8 and 5 will be 13, minus 7 will be 10 to the power 6. Okay. And from here we will be having under root 2 pi into 10 to the power 6. Okay. Under root 2 pi into 10 to the power 6. So that will give us the answer that I am having is 2.51 into 10 to the power 3 Nepper per meter. So that will be the alpha value. If we have to find the skin depth, denoted by delta, then this is equals to 1 by alpha, or what we can write it that this will be equals to 2 upon omega mu into sigma. Alpha we have determined, so we have to just reverse it. 1 upon 2.5 into 10 to the power 3. So how much we are going to get? We are going to get 2.4 into 10 to the power minus 3 meters. So that will be the skin depth. Okay. So that will be the skin depth. So once we have found out what is the value of alpha, okay, and alpha, there are different formulas regarding alpha. So first of all, we have to find whether it is good conductor or good dielectric. We have different formulas for alpha. Okay. So this is how we are going to calculate the thing. So as per the option number B is the right answer for this question. So this is how we can solve this question very easily. Okay. So let me move to the next question. The purpose here is to give you the flavor of all kind of problems, that can be the probable one for the upcoming GATE exam. Okay. So what I have done here, I have chosen problem, or I have designed problem from all the topics from where I can expect a gate question from this chapter. Okay, so right now we had flavor of this question. Now have a flavor of this question. This will also give you a better learning. Okay, pointing vector and average power. So let us solve this question. What has been given here is an electromagnetic wave is traveling between free space and glass. So from free space it is going into glass. Okay, and glass is having zero conductivity. Epsilon r is 4, mu r is 1. If plane wave with electric field E equals to 4 cos omega t minus pz, volt per meter is incident from free space to glass, then time average power transmitted through a 2-meter path of interface will be. Okay, so we have to find the time average power transmitted through the glass. Thank you, Nikhil. So what we have to find? We have to find what is the power, average power transmitted into the glass. Okay. So wave is traveling from air, free space to the glass. So guys, can you solve this question? Let me give you some time for this. Have a thought about it. Okay. So I am giving you 1 minute. Have a thought about it. Just try to think, can you solve this question? It's very easy. Last 5 seconds. Okay, just see what we can do in this question. What we have to find? We have to find the time average power transmitted. Okay, so what will be the power transmitted? Okay, power transmitted, first of all you have to calculate the power transmitted. Okay, once you have found out what is the power transmitted, the time average power, so average power will be power transmitted into the area. Okay, so first of all you have to find the power transmitted, and then you can calculate the average power by multiplying this to the area. Okay, so how to find the power transmitted? So you know that relation, that power transmitted PT, that is equals to 1 minus reflection coefficient square into P incident. Okay, so that is the formula. So we need the value of gamma L, that is the reflection coefficient. We need the value of incident power, and then we will be able to determine all the things. Okay, so how to approach for this problem? So first of all, what will be the incident power? So if we are going to calculate the incident power, so incident power, the wave is coming from air, free space. So incident power will be EM square divided by twice of neta. Okay, what is EM? EM is given 4, so that will be 4 square, and for air impedance is 120 pi. Okay, impedance is 120 pi. So this is how you can find out what will be the value of P input, and the value that I am having for P input is 1 by 15 pi watt per meter square. Okay, let us write it in this manner. Is it correct? 4 square divided by 2 into 120 pi. Okay, so that will be 16, or it will be 8. Yes, it is correct. Okay, so that is P input. So we have the value of P input right now. Okay, now in order to calculate P average, we need the value of gamma L, isn't it, as per the formula? So we don't know what is the value of gamma L. So what it requires, gamma L, if we talk about gamma L, reflection coefficient, we need to have impedance of the two medium, isn't it? We need to have the impedance of the two medium, and then we will be able to calculate it. So neta 1 will be 120 pi because it is space or air, sorry, free space or air. And in the second medium, what will be the neta 2? So for second medium, neta 2 will be 120 pi into mu r over epsilon r. Okay, so it will become 120 pi, mu r is 1, epsilon r is 4. 120 pi divided by 2, that is 60 pi. So now we know the value of neta 1 and neta 2, so we can find out what will be the reflection coefficient. So what will be the reflection coefficient? It is neta 2 minus neta 1 divided by neta 1, neta 2 plus neta 1. So just put the values here. Neta 2 that we have is 60 pi minus 120 pi divided by 60 pi plus 120 pi. So how much it will be? It will be 60 pi divided by 180 pi. So we will be having minus of 1 by 3. So gamma L is with us right now and it is equals to minus 1 by 3. So what we can do, we can calculate the power transmitted. Okay, let me remove this. So we can calculate the power transmitted very easily. So the power transmitted will be 1 minus gamma L square into the incident power. So how much we are going to get? 1 minus 1 by 3 square into the incident power that we have is 1 upon 15 pi. How much we are going to get? This is 1 by 9 and 9 minus 1 will be 8. 8 by 9 into 15 pi. This is what we'll be having. 8 upon 130 pi, isn't it? 8 upon 130 pi watt per meter square. Yes or no? 8 upon 120, 8 upon 135 watt per meter square. Now if we have to calculate the average power, that will be the power transmitted, which is 8 upon 130 pi into the area. Area is given 2 meter square. So multiply with 2 only. So it will be 16 upon 135 and 16 upon 135 you will be getting 37.72 milliwatt. That is the answer that I am having. Okay, cross check from your own side as well. 37.72 milliwatt will be the answer. So this is how we have to proceed for this question. Okay, so the way we are proceeding this, the kind of expressions required for it, those are very important for you. The same kind of questions you can expect in the upcoming GATE exam as well. Okay, so if you have practiced these enough, there is a guarantee of your success in the GATE exam. Okay, so this is how we will solve this question. Let me move to the next question, question number 5, and this is going to be a tricky one. What has been given here is in a certain medium, epsilon r and mu r are 4. A plane wave is propagating such that the electric field intensity of the wave is given by this expression. What will be the loss tangent of the medium? So what we have to calculate? We have to calculate the loss tangent. Okay, loss tangent means we have to calculate sigma upon, loss tangent means we have to calculate sigma upon omega epsilon. What will be the value of sigma upon omega epsilon? That is what we have to calculate here. So this is required to be calculated. Now how to solve this question? How to approach for this kind of question? Okay, so first let me check you. So I am giving you 1 minute of time again, and let me see whether my students can solve this question or not. I will be very happy if you will get an answer. Okay, so just think for it. Think for it and try to approach this question. So just see this expression of this wave, okay? So if we just look into the expression of this wave, what has been given to us is this wave can be written like this, isn't it? E is equals to E naught or EM, okay? We used to write EM, but we can also write E naught, that is the maximum value. E to the power minus alpha, the direction here is x, so alpha x, okay? Sine of omega t minus beta x, isn't it? So if we compare here, the value of attenuation constant is given to us, and that is 1 by 3. Okay. So this is not a perfect dielectric. So alpha is 1 by 3. And what is the value of omega? Omega is basically 10 to the power 8. That is what is given to us. Okay. So this data we are having. Now we have to find sigma upon omega epsilon. What will be the ratio of this? How we are going to approach for this ratio? So guys, you know that the value of alpha, the attenuation constant, we have a formula for attenuation constant in general formula, and from where we have drawn a lot of conclusion, that is equals to this much. Okay, that is equals to this much. Okay, attenuation constant alpha is given by this formula, and this formula is what you have to practice a lot. Omega under root mu e upon mu epsilon by 2 under root again 1 minus omega upon sigma upon omega epsilon, okay, and this is not minus, this is plus, minus will be here, okay, 1 plus sigma upon omega epsilon square minus 1. If suppose we have to calculate beta, only plus will be there and rest of the things will remain same. So this is where we are getting sigma upon omega epsilon, which is known as loss tangent, and that is what we have to determine, okay. So let me assume that this quantity 1 plus sigma upon omega epsilon is square, okay. Let me assume that this quantity is x. So if I am writing this to be x, alpha can be transformed into omega under root of mu epsilon divided by 2, okay, under root mu epsilon by 2. I have assumed the inner quantity to be x, okay, and let us assume this whole quantity with under root to be x. So what we can write now? So this will become x naught, sorry, this will become x minus 1. Can we write it like that? Isn't it? If we are writing it to be this will become this quantity. Yes or no? This will become this quantity right now. Now, if suppose we want to find x, how we are going to find x? For that we need to square it up, isn't it? So this will be alpha square equals to omega square, and here we will be getting omega epsilon divided by 2x minus 1, okay. Now what is x? So if we have to find x, okay, that will be what? Be very careful with the solution. So x minus 1, that will be equals to 2 alpha square divided by omega square mu epsilon, okay. And what will be x then? X will be 2 alpha square divided by omega square mu epsilon minus 1 or plus 1, okay, isn't it? This will be the value of x, okay. Or what we can do, let it be in this way, do not solve it further. So we can write it 2 alpha square, okay. Let us find this quantity x minus 1. Omega square mu into epsilon can be written as mu naught epsilon naught and mu r into epsilon r, okay. Now you know that what is c? C is basically 1 upon under root mu naught epsilon naught, and this is equals to 3 into 10 to the power 8 meter per second. So can we replace this with this expression? So this formula will become 2 alpha square c square divided by omega square mu r epsilon r, isn't it? Now guys, what we have to do, we have to put the values here. So x minus 1, this quantity will be 2 times, what is alpha? Alpha is 1 by 3, isn't it? So this will become 1 by 3 square. C square means 3 into 10 to the power 8 square divided by omega. What is the value of omega? Omega is 10 to the power 8. 10 to the power 8 square into what is mu r and epsilon r? They are given 4 into 4. Okay. So now we have to solve this equation. So after solving this equation, what will be the value of x minus 1? Once you will solve this equation, you will get the value of x minus 1. Okay. And that value will be 1 by 8. Okay. That value will be 1 by 8. 10 to the power 8 square will get cancelled. We are getting what here? We are getting 1 by 9, 1 by 9, and 9 will be getting cancelled. We are getting 2 upon 16, that is 1 by 8 here. So x minus 1 that we have obtained is 1 by 8. So x minus 1 is basically 1 by 8. What is x? So x will be 1 by 8 plus 1, that is 9 by 8. And what is x? We have assumed that x is 1 plus sigma upon omega epsilon. Okay, and square is also there. Now this is equals to 9 by 8. Just square it. So on squaring, what you are going to get? On squaring, you are going to get this quantity. Okay, sigma upon omega epsilon square will then become 81 upon 64 minus 1, or what we are going to get? 81 minus 1 upon 64. Okay, that will be sigma upon omega e f square. Okay, so what will be sigma upon omega e? That will be equals to under root of 81 minus 1 upon 81 upon 64 minus 1. So finally, when you are going to solve it, you will get your answer. Okay, so the answer that I am having is 0.52. 0.52 will be the value of loss tangent. Okay, so the loss tangent, that is sigma upon omega epsilon, will be equals to 0.52. So this is how we have approached for this problem. Now I recommend to practice this kind of problem, okay, because this can be a probable gate question in the upcoming gate exam. So this is how we have to solve for, this is how we have to approach for this question. Okay, so I don't feel there is any problem. You can solve this easily. So let us move to the next question that we have. Okay, now can you solve this question? The expression for 2 sigma upon omega epsilon in terms of attenuation constant alpha and phase constant beta will be which one of these? Okay, so what we have to find out? We have to find out the expression for 2 sigma upon omega epsilon. Okay, 2 sigma upon omega epsilon, guys. Sigma upon omega epsilon, this is known as the loss tangent. Yes or no? This is known as loss tangent, and you have to find what will be 2 sigma upon omega epsilon. Okay, so basically you have to find this ratio. So can you do this problem? You can do this problem very easily. You can solve this problem very easily, isn't it? Let me give you 1 minute and let me see whether you can solve this question. So you know that the propagation constant, okay, we have propagation constant, okay, known as gamma, and we know that gamma square is basically equals to what? J omega mu sigma plus J omega epsilon, isn't it? Or what we can write, gamma is basically alpha plus j beta. So this will be alpha plus j beta square. If we multiply this, we will be getting j omega mu into sigma minus omega square mu into epsilon. Okay. Now what will be this? Alpha square and minus of beta square plus twice of j alpha beta. This will be equals to j omega mu sigma minus omega square mu epsilon. On comparing, what you will obtain? On comparing, you will obtain get alpha square minus beta square. That will be the real part, which is minus omega square mu epsilon, and alpha twice alpha beta. That part that you will be getting is omega mu sigma. Yes or no? This is what we will be getting here. Yes or no, guys? This is what we will be getting here. So these are the two equations that we have. Okay. Let me call this equation 1 and let me call this equation 2. What we have to find? We have to find sigma upon omega epsilon. Okay. So on dividing equation 2 by equation 1, let's see what we are going to get. So if we are doing equation 2 by equation 1, means if we are dividing twice of alpha beta by alpha square minus beta square, we will be getting here omega mu sigma divided by minus omega square mu epsilon. So this get cancelled, this power get cancelled. What we will be getting is minus of sigma upon omega epsilon. Yes or no? Minus of sigma upon omega epsilon. So we can consume this minus if we are going to write it sigma upon omega epsilon, and we are going to multiply it with 2, and by consuming minus we will be getting 4 alpha beta divided by beta square minus alpha square, or we will be getting 4 alpha beta divided by beta plus alpha into beta minus alpha. Did we have any option here? Yes, we have an option, isn't it? So this option, which is this option that we have, option number B, 4 alpha beta upon alpha beta beta minus alpha, will be the correct answer. So this is how very easily we can solve this question. We have to write this factor in terms of alpha and beta. Okay, so this is a very important question. Okay, this is a very important equation. Sorry, this is a very important equation. Through this you can derive all the cases. Actually, this is an equation from where actually all the cases have been derived. So you have, if you can remember this, you can solve any question very easily. Okay, so let me move to the next question. So just see this question right now. A uniform plane wave is propagating at a velocity of 7 into 10 to the power 7 meter per second. Okay, in a perfect dielectric such that the electric and magnetic fields of the wave are also given. What will be the relative permittivity and permeability? We have to find what will be epsilon r and what will be mu r of the medium. Okay, so E and H are given, and the velocity in the medium is also given to us. So velocity in the medium is given. Okay, so velocity in any medium is what? 3 into 10 to the power 8 divided by mu r into epsilon r. This is given 7 into 10 to the power 7. So how much will be under root of mu r epsilon r? How much will be this quantity? So this will be 3 into 10 to the power 8 divided by 7 into 10 to the power 7. So this will be 30 by 7. Yes or no? So this we have obtained. Let me call this equation number 1. Second, you know that E and H are given to us. So if we are trying to find the ratio of E and H, okay, so the ratio of E and H, is known as neta. Okay, and that ratio will be what? 900 divided by 1.9, and neta, as you know, is given by 120 pi under root mu r upon epsilon r. This is given 900 upon 1.9, or mu r upon epsilon r, that will be 900 upon 1.9 into 120 pi. Let me call this to be equation number 2. Isn't it? Can we find these two equations from the given data? Okay, can we find these two equations from the given data? Now, from these two equations, if you just multiply these two equations, okay, so equation 1 and equation 2, if suppose we are going to multiply equation 1 with equation 2, what we are going to get? So on simply multiplying this equation, what we will be getting? Mu r, epsilon r will get cancelled and we will be getting mu r. This will be equals to 30 by 7 into 900 divided by 1.9 into 120 pi. Okay, so from here, if you will solve it, you will get the value of mu r, and the answer that I am having is mu r is 5.38. Okay, mu r that I am having is 5.38. That is the correct answer. Now place anywhere. So if you are going to place the value of mu r, you will be getting the epsilon r. Okay, in any of the equation 1 or 2, and epsilon r will be found out to be equals to 3.4 then. Okay, so epsilon r will be 3.4. So this is how you can solve this question, 5.38 and 3.4. So that is going to be the correct answer, option C. So this is how you can solve this question very easily without any problem. Okay, so now let me move to the next question. Question number okay, 8 we have done first, then we are going to solve 7. So a perpendicular polarized wave traveling in lossless medium, mu r and epsilon r are given to us. A perpendicular polarized wave. So perpendicular polarization is the case. We can expect a gate question from this particular topic. Perpendicular polarization. Okay. In a lossless medium, mu r epsilon r is given. Lossless medium is there, is obliquely incident at an angle of 30 degree. So what is given to us? Theta I. Theta I is given 30 degree. Okay. With respect to normal on the non-magnetic slab. Non-magnetic slab means mu r2, that will be equals to 1. Okay, and mu r1 will be, what is mu r1? Mu r1 that we have is equals to 4 here. Okay, and what is epsilon r1? Epsilon r1 that we have is 1. We don't know what is the value of epsilon r2, that is not given to us. Okay, so a perpendicular polarized wave traveling in a lossless medium with these factors, incident at an angle 30 degree with respect to normal on the non-magnetic glass slab. Okay, with a refractive index of 1.5. So refractive index in this case mu2 is given to us 1.5. So refractive index is given in this case. Okay, we have the value of refractive index. Is it visible? Not visible. So let me draw it here. Mu r2 is what we have, equals to 1. Yes, non-magnetic slab. Epsilon r2 we don't know, and refractive index is given to us. What is refractive index? Refractive index is given 1.5. Okay, the reflection coefficient will be what? We have to find what will be the reflection coefficient. Okay, what will be the value of reflection coefficient, that we have to find, and it is a case of perpendicular polarization. So in case of perpendicular polarization, you know that the reflection coefficient is neta 2 cos of theta I minus neta 1 cos of theta t. Okay, theta I theta t divided by neta 2 cos of theta I plus neta 1 cos of theta t. So what do we require? We require the value of neta 1, we require the value of neta 2, and we require the theta t angle. Okay, theta I is given to us. So if suppose we are having all the values, we can solve this question very easily. Yes or no? So if we talk about medium 1, so for medium 1, what will be neta? Neta 1 will be 120 pi under root of mu r upon epsilon r, isn't it? Mu r1 upon epsilon r1. So this we can calculate. This is given 4 divided by 1. So this will be what? This will be equals to 240 pi ohms. This will be neta 1. Now what will be for medium 2? If we talk about medium 2 will be having 120 pi under root of mu r2 divided by epsilon r2. Okay, so mu r2 is what we have equals to 1. Okay, and what will be the value of epsilon r2? What will be the value of epsilon r2? So if you know about refractive index, okay, so refractive index, okay, whom we denote by mu, this is equals to under root of mu r into epsilon r. So in this case mu r is 1 and epsilon r is what we need to calculate. Okay, so refractive index we have 1.5 and under root mu r. So under root mu r will be 1.5. So we can directly place this value, isn't it? So this will be what? This will be 120 pi divided by 1.5. Okay, so 120 pi divided by 1.5, this will be 80 pi mu, 80 pi ohms. So that will be the neta 2 value. Yes or no? Refractive index is basically equals to under root mu into epsilon. So for medium 2, refractive index is given. Okay, mu is given 1. Epsilon is what we have to find. So under root epsilon, that will be equals to 1.5 and we can calculate neta 2. Now we require to calculate theta t. If suppose we have the value of theta t, this problem is almost done. Yes or no? So how to find theta t? Now you know that sine theta t divided by sine of theta I, okay, that is equals to what? That is equals to mu 1 upon mu 2. Both are refractive indexes. Okay, mu 1 upon mu 2, both are refractive indexes here. Okay, now mu 1 upon mu 2, how to find these? Mu 1 upon mu 2 means this will be under root of mu r1 epsilon r1 divided by mu r2 epsilon r2. Just put the values. Just put the values here. How much we will be getting? Under root mu r1 and in epsilon r1. Mu r1 epsilon r1 is 4 into 1 divided by mu r2 epsilon r2. What is mu r2? This is 1. Epsilon r2. What is epsilon r2? Epsilon r2 will be 1.5, isn't it? Under root epsilon r2 will be 1.5. So we can directly write 1.5 here. Okay, from this equation we can directly write it here. So this will give us 2 upon 1.5. Okay, so now sine theta t, this will be 2 upon 1.5 sine of theta I, and this will be 2 upon 1.5 sine of 30, or 2 upon 1.5 into 1 by 2. So we will be getting 2 by 3. Sine theta t will be 2 by 3. So how much will be theta t? Theta t will be sine inverse of 2 by 3. How much it is going to be? Sine inverse of 2 by 3. The value that I am having is 41.8 degree. Okay, so this will be 41.8 degree. Now guys, we have calculated all the things. What is neta 2? Neta 2 is 80 pi. Cos of theta I is 30 minus neta 1 is 240 pi. Cos of theta t is 41.8, isn't it? Just repeat these quantities in the denominator as well. 80 pi cos of 30 plus 240 pi cos of 41.8. Now, what else is required? You only have to solve this equation, isn't it? And answer that you will be getting is minus 0.4446. So that is going to be the answer. This is how we can solve this question. Okay, so in case of perpendicular polarization, what is the formula of reflection coefficient? That is what you have to practice. And then you know Snell's law, refractive index, neta, all those things you can calculate very easily, and this question will be done. Okay, so this is how we can solve this question. Move to the next question. Just focus on this question. What is given here? A parallel polarized. After perpendicular polarization, now we are having parallel polarized case. So a parallel polarized wave impinges on a very thick sheet of plastic at an angle of theta I equals to 30. Let us write the given data. What is given to us? Theta I. Okay, so theta I is given 30 degree. And from one medium it is impinging on plastic. Okay, from free space. So from free space it is going into the plastic. So for free space, neta 1 will be 120 pi. Okay, relative permittivity of the plastic is, relative permittivity of the plastic means epsilon r2 is given 4, and its relative permeability mu r2 is given 1. Okay, the percentage of incident power, what will be neta 2 here? Neta 2 will be 120 pi under root of mu r2 divided by epsilon r2, or what we can get from here is 60 pi ohm, isn't it? So that will be neta 2 value. We have to find the percentage of incident power that is transmitted to plastic medium and Brewster angle. We have to calculate the percentage of power transmitted. Percentage of power transmitted means we have to find Pt upon P input, and that is equals to 1 minus gamma L square. Okay, so this is what we have to calculate, and then we have to calculate what will be the Brewster angle, theta B. These two quantities are required to be calculated. Okay, these two quantities are required to be calculated here. So what to do? From perpendicular polarization, now we have parallel polarization case. Okay, so first of all, just apply the formula. What is the formula of gamma? Gamma right now will be, just see here, what we have written here, neta 2 cos theta I. Now I will be replaced with t. It will be cos of theta t minus neta 1 cos of theta I. Okay, divided by neta 2 cos of theta t plus neta 1 cos of theta I. So how, this is how the things will be modified. Okay, in perpendicular polarization, first we will be writing theta I. In parallel, first we will be writing theta t. So theta I is given to us. So first of all, we have to calculate theta 2, isn't it? So theta 2 t, theta t we have to calculate. So what will be theta t? Just calculate theta t. So you know sine theta t divided by sine of theta I. Okay, so from the last case what we have seen, this will be equals to what? Sine theta I, theta t upon theta I, that will be equals to under root of mu r upon, let me write it. Mu is not a concern here because it is given 1. So we can write epsilon r1 divided by epsilon r2. Okay, so this will be equals to what? This is 1, and epsilon r2 that we have is 4. So we will be getting 1 by 2 here. So after that, what will be sine of theta t? We will be getting sine of theta I divided by 2. Sine of theta I, that is sine of 30 divided by 2, that is 1 by 4. So how much will be theta t? So from here, theta t, if you will calculate sine inverse 1 by 4, you will be getting 14.48. Okay, so 14.48 will be the value of theta t. So first we have calculated theta t angle. So this task is done. Theta I is given to us. Neta is what we require. Neta is also known to us. So just put the values here. Neta 2 is 60 pi. 60 pi cos of theta t, 14.48, minus neta 1 is 120 pi cos of theta I is 30 degree, divided by, repeat the same thing, 60 pi cos of 14.48 plus 120 pi cos of 30. So once you will solve this, you will get the value of gamma. Okay, so how much will be the value of gamma? This is coming out to be minus 0.28. Okay, this is coming out to be minus 0.28. Now what we have to calculate? We have to calculate Pt upon P input. okay, or transmitted upon incident wave, this is equals to 1 minus gamma L square. So 1 minus 0.28 square, okay. How much we are going to get? 1 minus 0.28 square, if you are going to do this, you are going to get 0.9216, or we can write 92.16%, okay. So one answer we have obtained, 92.16 or approximately 92.2%. So we have found out this ratio. Now tan theta B, that is Brewster angle, if you have to find, tan theta B is equals to epsilon R2 divided by epsilon R1. What is epsilon R2? That is 4. 4 divided by 1, that is 2. So how much will be theta B? How much will be theta B? That is tan inverse 2. Okay, so tan inverse 2 will give you 63.43. 63.43. So B is going to be the correct answer. This is how we can solve this question. So either perpendicular polarization or parallel polarization, any one of the cases you will definitely see in the upcoming GATE exam. So both type of questions we have practiced here, okay, and this is the advantage of this series, to make you aware of all the important concept, to give you the practice of all the important concept, and I hope that this series is serving its purpose. Now moving to the last question. Moving to the last question of the day, question number 10, and this is related to polarization. Polarization is also one such topic which is very, very important. Okay. Now what is given here is electric field of uniform plane wave is given by this equation. Okay. This equation. Then polarization of the wave will be what? So what kind of electric field is given, and how we used to write? How we used to write the electric field? Electric field is normally the direction of traveling is z direction. So we used to write it E of mx cos of omega t minus beta z unit vector x, okay, plus E of m y cos of omega t minus beta z direction y, okay. Now what kind of field is given to us? We have been given that E is equals to 2 cos omega t plus beta z, okay. If this is the equation, that means the wave is traveling in positive z direction, okay. The wave is traveling in positive z direction, okay. The wave is traveling in positive z direction. But what has been given to us is, we have been given that the E is equals to 2 cos omega t plus beta z unit vector x plus 5 sin omega t plus beta z unit vector y. So what we can write it, this will be 2 cos omega t plus beta z unit vector x. We can write this to be equals to 5 of cos omega t plus beta z minus pi by 2, isn't it? We can write this. Now here, if equation is in like in this manner, good evening, good evening. So if the equation is in this manner, we used to say that the wave is traveling in positive z direction. It is having component is x and y direction. But what has been given to us is plus beta z. So if we have plus beta z, what it indicates? It indicates that the wave is traveling is minus z direction. So if the wave is traveling in minus z direction, so what has been right will become left, what has been left will become right. But the nature of line is circular or elliptical will remain same. Only the right will become left, left will become right. Now just see here, if we compare, E of mx is not equal to E of my. So this cannot be the circular polarization, okay. Phi is not 0, even phi is equals to minus of pi by 2. Phi is equals to minus of pi by 2. Okay, so E of m is not equals to E of my because 2 is not equals to 5 here, okay. And if the wave is traveling in positive z direction, with all these cases, we used to say that this case is right circular polarized, isn't it? In this case, the wave will be right elliptically polarized. Okay, we used to say that this is right elliptically polarized. This is the case of right elliptical polarization. But can you see, everything is same, okay, everything is same, but in our case the direction is what? The direction that we have is minus z direction. So if the direction is minus z direction, what is right will become left. So this waveform that we have will become left elliptically polarized. Okay, left elliptically polarized. Fine. With these cases, if positive z direction is there, it is right elliptical polarized. But if the direction is opposite, with the same case, it will become left elliptically polarized. If the magnitudes were same, it will be circularly polarized. Okay, elliptical will become circular. Instead of phi equals to minus pi by 2, if we have pi by 2, this right will become left, and then this left will become right. Okay, so this is what you have to take. So which option will be correct here? Option number B. Option number B here, which is left-handed elliptical polarization, will be correct. In case of polarization, okay, do not forget to check for the direction of wave traveling. It is minus z here. Okay, it is minus z here. What you have practiced in class is for positive z. If the direction is minus z, left will become right, right will become left. So do not forget this particular case whenever you are solving any problem related to the polarization. Okay, so guys, this is the end of the class today. We discussed almost 10 students and I have touched almost each and every important point. Okay, so just practice all these questions and all these areas from where I have picked the questions, and all these questions and all these topics are going to be the probable one in the upcoming GATE exam. So this is how it will help you. Okay, now in the next Friday I will be here again with a very important topic, and a topic which almost 90% of students used to left, and that is nothing other than but the antenna. Okay, so thank you for being there. Thank you for watching this lecture. I will be live again on the next Friday with the most important topic, antenna. So thank you so much.